Let's show a parametric equation represents a parabola. We've discussed what parametric equations are, right? They're basically just two functions that have they're two functions of a common variable. So let's see an example. It says that x is equal to at squared. What that basically means is that x is a function of t, right? So in this case, f of f1 of t, the first function of t, is equal to at squared. And the second y is equal to 2at. So f2 of t is equal to 2at, right? And it represents the equation of a parabola, which is basically y squared is equal to 4ax. We need to show that these two parametric equations of x and y are equal to the equation of the parabola, right? So let me just rub this off for now. I just need to show you how they were functions of a common variable t. Now let's see. This is given to us and this is given to us, right? So let's see. We need to isolate t over here in this second equation, right? So take this 2a to the left hand side, so it becomes y over 2a. T is equal to y over 2a, right? Now that you have this value of t, replace it in this function, in this equation over here, right? So this t square over here becomes y over 2a. So x into at squared becomes now x is equal to a into y over 2a whole square. Now further simplify it, and basically now just cancel out this a with one of the a's over here, right? So just this 2 becomes 1, so that becomes y squared over 4a. And now you take this 4a to the left hand side and multiply it with x. So y squared is equal to 4ax. We've proven that y squared is equal to 4ax, and that is the equation of the parabola.